The answer key to homework 3.6, which is part of a B. So key. That's cool. Should have been graphic designer. Look at this. Oh, look how cool this is. I need to talk to Mr. Wall. A little branding. All right, can we justify that these are right angles? Heck yeah. Because that's a perpendicular bisector construction. The diagram is a perpendicular bisector construction. So those angles are right angles. AG, BG, CG, DG. AG. Oh, G is the middle of the little circle, right? G is center of lil circle. So those segments are all radii of circle G. Circle G. Earthquake. No, just kidding. That's not funny, Mr. Abden. A B G C B G A D G C D G. It's the little ones. Why are those all congruent? Side angle side. Using statements in number 1 and number 2. Does that make sense? In statement 1, we established these are all right angles in here. In statement 2, we established that these are all the same length, and those 4 triangles have these sides. Side, angle, side, side, angle, side, side, angle, side. So all 4 of these little triangles are congruent. How about these? A, B, B, C, C, D. Those are oops, I'm not on the screen at all. Corresponding parts of congruent triangles, so they be congruent. C, B, C, D, C. What lines are we going to add? Okay, so here's the cool thing. We're trying to prove that this and this are the same. But we need to add, I mean, there's no way to just say it. You gotta, but adding this line here and this line here allows you to attempt to prove these 2 wedgy triangles are the same, congruent. If these 2 wedgy triangles are congruent, then this side, this corresponding, we can use CPCTC. Corresponding parts of congruent triangles are congruent. Okay. We know that oh gosh. Okay, we don't actually have to prove it, right? How might this addition of an auxiliary segment be used in the proof? Well, if we can prove these 2 wedge triangles are congruent, then the little segments will be congruent. It is possible. Basically, what you do is you prove that these two bigger triangles are congruent. They go all the way to here. And then you prove that these little triangles with these angles are congruent. And so these angles all match. And then if you subtract the big angles that match from, or if you subtract the little angles that match from the big angles that match on each side of that line, then you get that this wedge angle must match. And if the wedge angle matches, well, we know these sides match because they're radii of circles. And so then we have side angle side. Once we have side angle side, then we have CPCTC. But you did not have to explain all that. You just have to see those lines and say, gonna try to do triangle. All right, what else do we got? Based on information in the statements or diagrams, it is possible to make claims about what is likely true. The claims made are considered conjectures because they've not yet been proven or disproven. For each problem, use the diagram and statements to generate at least one conjecture. About the quadrilateral, attempt to conjecture about the most precise classification for the quadrilateral. What are we given? Tra is congruent to var. So we gotta, okay, we can mark this up. TR, VA. This is same side. I'm not gonna mark it. We're too advanced. And then, so these are congruent triangles. It says right here, congruent triangles. Okay, well, this angle, I mean, how can we prove these lines are parallel? I think if we prove that they make the same angle in the same spot, that should be sufficient. Well, let's just conjecture it. Parallelogram. Actually, to be more precise, sometimes you see this symbol. TRVA, parallelogram, or quadrilateral TRVA is a parallelogram. Bam! Great conjecture. Best conjecture ever. ABC, and DEC. So this angle and this. And that's congruent to itself, but this means also that this and this and this and this. Aha. This is a trick. Look, these lengths. No, that's not. I messed up. I thought for a second that it had to be a rectangle, but I think it's a parallelogram again. Does it have to be a parallelogram? Okay. REH, triangle REH is congruent to triangle AEC. And triangle REH and triangle AEC are isosceles triangles. I'm conjecturing it's a rectangle then. Check this out. Those are vertical. Side angle side. Now these have to be the same because side angle side, side angle side, CPCTC. But every corner has, okay, since these are isosceles, I'm looking at this isosceles. This base angle and this base angle are the same, and this one are the same. And AEC and REH are isosceles also. So this angle and this angle are the same, and this angle and this angle are the same. And now all four corners have a single mark and a double mark angle, which means all four corners are the same size. Quadrilaterals all have 360 degrees inside of them, but all four angles are the same, so divide by 4, and all four angles are 90 degrees. So you didn't have to do all that, obviously. You just had to conjecture. You didn't even have to get the right conjecture. Conjecture. This is quadrilateral. Is it a trapezoid? Doesn't look like a trapezoid. Sometimes, okay, so just saying AC, ABDC is a quadrilateral, which means it just has four sides. There's nothing special about it. Quadrilateral. No, notice I can't say ABCD because ABCD is not a quadrilateral. You have to go around the quadrilateral. ABDC or ACDB. All right. Let's wrap it up. Avden. Here we go. Given reh and ich and rech and ech are isosceles right triangles. Oh, well then I conjecture this is a square. Yeah, because if these are right angles, then these are all right angles, and these are all the same size, then these are all congruent triangles, and then these are all the same length by CPCTC, and if these are isosceles right triangles, these have to be 45 degrees each. If they're all 45 degrees, then they have 90 in the corners, so it's a square. But again, you didn't have to prove it was a square. You just had to conjecture it was a square. Or even you could have conjectured something else. But square's the best thing to conjecture. Skip the go. I had like 5 students walk up to me like, I don't remember how to do this. And I said, you didn't watch the video, because at the end of the video I said, skip the go. Okay, some of them said they just stopped the video early because they thought they knew everything. But, you know, that's life. Happy Wednesday.